Good day. First question. What is fluid? Fluid is a state of matter that yields to sideways of sharing force. Liquid and gases are both fluids. Fluid statics is the physics of stationary fluid. Fluid in a liquid or gas or generally are material that cannot sustain a tangential or sharing force when at rest and undergoes a continuous change in shape when subjected to such a stress. Problem set number 2. Example 14.1. What force must a dam withstand? Consider the pressure and force acting on a dam retaining a reservoir of water. Suppose the dam is 500-meter wide and the water is 80-meter deep at the dam. As illustration below, what is the average pressure of the dam due to water and calculate the force exerted against the dam. The average pressure P due to weight of the water is the pressure of the average depth height of 40 meters. Since pressure increases linearly with depth, the force exerted on the dam by the water is the average pressure times the area of the contact force times pressure times area. So solution for A, we must find the pressure. We use the equation pressure is equal to height times rho times gravitational. So our height here is 40.0 meter and our P is 10 cube kilogram meter cube and our gravitational we know that 9.80 meter per second square. So ang answer sa pressure is 3.92 times 10 raised to the power 5 Newton meter or 392 kPa. So let's proceed. We solve for B, which we use the equation area is equals to 80.0 meter which muna itong height ng 500 meter muna ang kaluagon. So we come up with the answer of 0.0 times 10 raised to the power of 4 meter cube. So therefore, nakita naman na to ang pressure o ang area, so we can solve the force. So force is equals to pressure times area, which our pressure is 3.92 times 10 raised to the power of 5 Newton meter square. Itong area is 4.0 times 10 raised to the power of 4 meter cube. So we get a force of 1.57 times 10 raised to the power of 10 Newton. Okay, let's proceed to example 14.3. Calculating force on wheel cylinder Pascal parts on the brakes. Problem. Consider the automobile hydraulic system shown in a figure 14.18. Suppose a force of 100 Newton is applied to the brake pedal which act on the pedal cylinder acting as a master cylinder through a lever. A force of 500 Newton is exerted on the pedal cylinder. Pressure created in the pedal cylinder is transmitted on the power wheel cylinder. The pedal cylinder has a diameter of 500 centimeter and each wheel cylinder has a diameter of 2.50 centimeter. Calculate the magnitude of the force to created at each of the wheel cylinder. So given our F1 here is 500 Newton and our A1 is 0.250 centimeter square and our A2 is 1.25 centimeter square. So find the force to so solution. Pascal principle applied to hydroelectric system is given by the formula of F1 over A1 is equals to F2 over A2. So suppose atong ipangita is force to maplastar na to niyang equation as a force 2 is equals to A2 over A1 times F1 is equals to pi r squared 2 divide pi r squared 1 times F1. So, ito ni sa substitute. Suppose our A2 is 1.25 cm square divide our A1 which 0.250 cm square times our F1 is 500 Newton. So, we come up with the answer of 1.25 times 10 raised to the power of 4 Newton. Muna siya itong force 2. So, for example, 14.4. So, Problem. Suppose a 60 kilogram woman floats on a fresh water with 97% of her volume submerged when her lungs are full of air. What is her average density? So in this problem, we must find the P person, which we use the equation of P person is equals to fraction submerged times P fluid. So our P fluid here is 97%. Ng fraction submerged is 10 cube kilogram meter cube. So ato ni say time, so we get the P person is equals to 970 kilogram meter cube. Continue for the example 14.5. So example 14.5, calculating fluid speed through a nozzle. A nozzle with a tumor of 0.500 centimeters is attached to a garden hose with a radius of 0.960 centimeter. The flow rate through the and nozzle is 0.500. Calculate the speed of the water and the hose be in the nozzle. So in this problem, we must find the speed of the water in the hose and in the nozzle. The solution, we first find the speed of the water in the hose. So we use the equation of volume is equal to flow rate divide area or equals to flow rate pi divide pi r square 1. So substitute our flow rate is 0.500 liter per second times 10 raised to the power of negative 3 meter cube liter divide 3.14 times 4.0 times 10 raised to the power of negative 3 meter square. So our volume here is 1.96 meter per second. So we solve for B, speed to the nozzle. So we use the equation of A1 times B1 is equals to A2 times B2. So ato ning pastarang equation, so we use the B2 is equals to A1 times A divide A2 times B1 or pi r square 1 divide pi r square 2 times B2 is equals to R2 1 divide R2 to B1. So substitute, we all know that our A1 is 0.900 centimeter square and our A2 is 0.250 centimeter square times our B1 or the speed of the hose which 1.96 meter per second. So ang atong speed to the nozzle is equal to 25.5 meter per second.